Hi everyone, I'm Tilakshana studying 8C in our national school. Today I'm going to talk about force of friction. Before we get into topic, let's know about force. So what is force? A push or pull of an object which causes motion is called force. For example, the opening and closing of a door. What happens when you push or pull the door? It moves. So by applying force, we can move objects. When we drive a car, we can stop, slow down, or speed up the moving object because of force. When we hit a ball with a bat, we are changing the direction. In clay art, force is used to change the shape and size of the object. There are two types of forces, contact force and non-contact force. Contact force occurs when the two objects are in contact. Non-contact force occurs even when the two objects are non-contact. Frictional force is one of the contact forces. Let's see about force of friction. As we know, friction is a contact force. It acts between the object and the surface. So, when one object is moving over another surface, it causes resistance to the motion. That resistance force, which opposes motion, is called friction. Friction always stops or slows down the speed of the object in the opposite direction. So, when motion is going in this way, friction acts in the opposite direction, making it to stop. If there is no contact, no friction. We can measure friction in the SI unit of Newton. Let's see a few examples that happen in our daily life. When we roll a ball, it comes to a stop. We are able to write on paper with the help of friction. The friction between our soles of our shoes and the surface helps us to walk. The same happens between the tires and the road. Friction produces heat, which helps a matchstick to light up. When we rub our two hands together, we can produce heat. Friction works on slides as well. We saw about friction in its examples. Now let's see what's causing friction, how friction works, and what's causing resistance. Friction is caused due to the interlocking of irregularities between the two surfaces in contact. Let's take a glance at this picture. When we look at the contact area, both surfaces look smooth. But in real, the contact area looks like this. See how irregular the surfaces look? So, when one object is moving over a surface, it gets locked between these irregularities, causing friction. This picture shows a magnified view of the smooth surfaces. So, a smooth surface has minute irregularities, while a rough surface has large amount of irregularities. Let's move on to factors affecting friction. Friction depends upon two factors: the nature of the surface in contact, like smooth and rough, and how hard the surfaces are pressed together. This experiment shows how friction works on different surfaces. When we roll a car down on a ramp on a glass, wood, and sand gravel surface, we can see that the car moves faster on the glass surface than on the wood and sand surface. This is because there is less friction on the glass surface. So, a smooth surface has less friction, so less force is needed to move. On contrary, the rough surface has more friction, so more force is needed to move. It also depends upon the weight of the object. There are four types of friction: static, sliding, rolling, and fluid friction. Static friction acts on the objects that are at rest. So, the applied force, for example, the box placed on the floor. To move the box, the applied force must be greater than the frictional force in order to move it. Sliding and rolling friction are both kinetic, as they act on the object that's already on the move or rolling. So, the least force is required as the surface doesn't have enough time to get locked between these irregularities. Hands rubbing, sweeping the floor, and ice sliding acts on sliding friction, while ball bearing, skateboard, and wheels on the ground acts on fluid rolling friction. Let's see about fluid friction. Fluid friction is just like other types. It also resists the motion, but on objects that are moving through liquids or gases. In physics, liquids and gases are called fluids. Fluid friction is called drag in liquids and air resistance in air. Fluid friction depends upon the speed of the object, the nature of the fluid, and the shape and size of the object. Let's see about fluid friction reduction and why we have to do this. As fluid friction resists the movement, ship and aircraft designers want to reduce the friction by modeling the object into streamlined shape, so vehicles can go fast and it can save energy. Birds and fish have streamlined shape in which the ends are pointed and the middles are broad. We can increase and reduce friction. To increase friction, we have to increase the roughness of the surface in contact. For example, the soles of the shoes can be grooved. Kabaddi and gymnast players apply coarse powder or soil to get a better grip. Tires of the vehicles can be treaded, and brake pads help to stop the vehicle suddenly. Let's move on to reducing friction. Friction can be reduced by smoothing or polishing the surface, by using oil, lubricants, wheels, and ball bearings. Using lubricants in engines help to reduce heat. We apply powder on the carom board so the striker can move smoothly. We can also apply rollers or wheels on the object so the object can move smoothly. Using ball bearings on ceiling fans and bicycles help it to reduce friction. So, by increasing and reducing friction, we can increase the efficiency of the object's movement. Friction is a necessary evil. Why? Let's see. Friction is necessary. With friction, automobiles can stop or slow down. We are able to hold or take things. It is necessary for riding on the surface. It plays a vital role on building constructions. Not to mention, it helps us to walk easily. Friction is an evil. It causes wear and tear on the soles of our shoes and tire tread and ball bearings, which leads to accidental situations. As we know, friction produces heat, and the excessive heat leads to breakdown of machines. As we know before, this can be rectified by reducing or increasing friction. Last but not least, friction may not seem that important, but without it, we can't stop moving, buildings would collapse, we can't plant any vegetation, and asteroids would enter Earth as there is no molecular friction on the Earth's surface. So, our so-called Earth will be nothing but the end. References? Thank you.